Hi there, my name is Mr. Chick and I'm here to tell you about forces and motion. This video has been designed to help students understand about both forces and motion and how they are related. I have a sequence of videos here that covers forces, motion, momentum, work, and energy. Okay, so we'll look at forces. There are many types of forces. In general, a force is either a push or a pull. There are four fundamental forces of nature. However, here we are looking at forces of motion. Here we will use a book to demonstrate the forces acting. Gravity is the force acting on the book to pull it down. However, the force is weight. It is the weight of the book. If the book did not have mass, gravity would not act on it to pull it down. If we put the book on the table, the book does not fall. This is because there is a force from the table holding the book up. This force is called the reaction force. The reaction force is a force a solid surface exerts against the force of gravity. If we push the book along the table, we apply an action force. A resistance force acts against the push of the book. The resistance force between the book and the table is called friction. All resistance forces are also known as counterforces, as they act against a force. When the book falls through air, a resistant force acts against it. This force is called air resistance. This is the resistance of the air resisting the movement of the book. If we throw the book with an action force, again a force acts against it. This force is again air resistance. We often call air resistance drag. Drag or air resistance acts in the opposite direction to which the object is moving. If we place the book on water or in any other fluid, a force acts. The force that acts opposes the force due to gravity. This is called upthrust. This is a buoyancy force that exists due to an increase in pressure with depth. If we hang a book on some string, a force acts against the pull of gravity. This force is called tension. This occurs if you stretch an object such as string or a spring. The opposite force to tension is compression. This occurs when you squash an object such as a spring. If we give the book some wings, like an aeroplane, another force acts. This force acts against the pull of gravity. It is called lift. It occurs due to a difference in pressure across the wings. This occurs due to the Bernoulli principle, as airflow over the top of the wing is faster. If we give the book an engine, it has another force. This action force causing it to move is called thrust. Gravity is the force that acts on an object to pull it towards the center of Earth. The weight of the object is the force that acts down. The weight of an object depends on two things, mass and gravity. The acceleration due to gravity on Earth is about 10 meters per second squared. Really it's 9.81. So weight equals mass multiplied by gravity. Your mass is how much matter you are made up of, or it's your resistance to a change of motion. This is measured in kilograms. Your mass is the same wherever you are in the universe. Your weight, however, is a force that is measured in newtons. Weight depends on gravity. Therefore, in space, you are weightless because there is no gravity. Okay, we'll look at Newton's laws of motion. First one, the velocity of an object will not change unless acted on by a force. This means an object will move in a straight line at a constant speed or remain stationary unless a force acts on this to change it. So, two examples here, a book on a table, it is stationary Unless another force acts on it, it won't move. The skydiver, again, the forces on it are balanced and he's moving at a constant speed as he falls towards the earth. Now, I'm going to skip the second law and go straight to the third one for a reason. So this third law, every force has an exactly equal but opposite reaction force. This says if an object exerts a force on another object, the object it exerts a force on will exert the exact same force back. These are called interaction pair forces. So this first example, we've got a kind of a wolf or dog here, or fox rather, and as it exerts a force on the ground by its feet, the ground exerts the exact same opposite force back on the feet. In this example, force exerted by the face on the paw is a result of the force exerted by the paw on the other dog's face. They're equal and opposite. Another example, force of rocket on hot gases come out of one end. The force of the hot gases push the rocket back. That is why rockets move. Here's another example. The apple is pulled towards the earth, but the exact equal and opposite reaction force is the apple pulling on the earth. Okay, so if every force has an equal and opposite reaction force, how do objects move? Well, this is explained by Newton's second law of motion. Force equals mass multiplied by acceleration. Let's say someone has a mass that is twice that of someone else. When he pushes the smaller person, he exerts a force. The smaller person exerts an equal but opposite reaction force. But because his mass is smaller, his acceleration has to be bigger, because the mass multiplied by the acceleration must equal the force, and the force must be equal for both of them, as it is an equal and opposite reaction force. Therefore, the smaller person accelerates away faster than the bigger person. I'll look at another example here. So, this can be applied to a situation such as a man firing a paintball gun. When the gun is fired, the paintball exerts an equal but opposite reaction force on the gun. The paintball has such a small mass compared to the man and the gun, so that its acceleration is much greater. You experience a small acceleration of the gun as it recoils back into you. Look at a further example. The same principle can be applied to the earth and an apple. The earth pulls the apple with a force. The apple exerts an equal but opposite reaction force on the earth. But because its mass is so much smaller, the apple's acceleration is huge. The earth's acceleration is not even detectable because its mass is so much bigger. Back to mass and weight then. Here we can see why weight is a force. Newton's second law says that the force is equal to mass multiplied by acceleration. Weight is mass multiplied by the acceleration due to gravity. Weight equals mass times gravity. Force equals mass times acceleration. You can see how these are one and the same. I've been Mr. Chick. I hope this video has been helpful to you. Thank you for watching.